Before we begin today's class, I'm going to take us on a little trip over to D2L. And you could see for the final exam, it's the information we've covered since the last chapter. Sorting, we had the selection, exchange, and insertion. You heard of those three generics back in 161. And we did sorts that you probably never imagined we could have done with the selection or the insertion, and etc. We did a heap sort, and heapify. We brought in percolate up, percolate down. Talked about the radix sort. We had the merge. We had both the binary, which was the power of two, and a natural one. We did Huffman codes. You did those without me, which that is an enjoyable lesson. Sorry I missed it. The AVL, Adelson, Velsky, Landis. Left rotation, right rotation, left, right, left. 2, 3, 4 trees. We move things down, we move things up. We just recently got into digraphs. We talked about adjacency matrix. We talked about an adjacency list. We did some breadth first and depth search, traversing through those. And of course, I said as we went through there, you see names of important men. Just one of those things that some of them might just stick. So that is what we are looking at for our final exam on Monday. Everything in that list sound familiar? See some heads nodding. That's good. That's real good. So yeah, wow, we covered quite a bit in the last 4 weeks. You take a look at that list, that's a bunch of stuff on there. Yeah. Okay. So we're going to finish up looking at these digraphs. We sort of talked about some of this today, and then we're going to look at the program that goes along with it that's actually pretty cool, and that's the traveling salesman program. So, all right, if I take a look at this directed graph, we've used this one a couple of times, and we dabbled with this just a little bit the other day. And basically, this is going to lead into that whole traveling salesman. I can get from A to F probably quite a few ways. I can go A, B, F. I can go A, D, C, D, C, B, F. So there's different ways of different path lengths. And what you see right below here is a chart like we started doing the other day when we were doing the breadth traversal. And I said if I started A, I can get to B, I can get to D, and I can get to E. And they are all of path length 1. Doing for me. It's kind of laying it out. From B, where can I get to? I can get to pretty much F. So I add F to the list and I jump out here and say, yeah, A could get to F by way of path 2. Nothing else from B. From D, I can get to D, I can get to C, and I can get to H. So those now became a path of length 2 to C and now to H. And from F, from E, remember this was our first cities or first stops. From E, I can get to just H. So I added H to the list. So here was B, D, E. From B, D, and E, where could I get to? They would be traversals of 2. So at the end of A, B, D, and E, I can get to from A to B of length 1, from A to C of length 2, from A to D of length 1, from A to E of length 1, A to F of length 2, and A to H of length 2. All right, so the three new ones that I'm able to get to, these would be of length 3. They would include F, C, and H. So any place new F gets is going to be a 3. Now, the problem here is these guys shouldn't have changed to 2. For some reason, this became a 2 and this became a 2, and there's a typo in the book. Because to get from A to E is still one stop the whole way. All right, if I go to F, is there any place new I can get to? Well, I can get to G and I can get to I. So G is now 3 and I is 3. So I'm pretty much done by what I can see. From C, can I get to anywhere new? Nope. From H, can I get to anywhere new? No. Now, I could keep going. I still have G and I, but I've already exhausted my city, so I would not have to keep going. But if there were new ones from G, all of a sudden I put W out here. So from I can get to W. That would be of length 4. So this table is one that for you to sit and look at it, it may take you some head scratching the first time, like it did me, especially with these two. And then it was just bottom line, it's mistakes. But is this now leading us into something we may be interested in programming? Not today, folks, not today. Okay. Next, If I go back to D2L, I will see code samples, chapter 16. Go load them up. They're now yours. Forever? Yes, you can keep them forever. Mm-hmm. Oh, what do I got? An adjacency list template. Yeah, there's some stuff going on there. A digraph class template. Oh my. That would be a lot of stuff in my digraph. Remember, we talked about a lot of functions. I have my traversal, depth first, uh, depth first. Looks like I hit one of those, and then I'm going to hit the other one recursively. Shortest path, nice. And oh boy, oh boy, oh boy, oh boy. Shortest path, okay. Shortest path in the network. This is what I'm going to have you get up and running. And then I think we're pretty much done for today, but you got to first of all understand what's going on. Include digraph.h. Okay, I need to make sure I copy and paste and download that. And I got some stuff going on here, but I also need network file.data. Grab template, network file, there's grass, da 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 da. And I need to jump to the textbook. It would be the NIOF book. It would be on page, I had it and I lost it. Page 907. 907. You're going to see network file. Okay, so network file. Take a minute and look at that. See if you can understand what's going on. Well, I have some stuff written in blue. Stuff written in blue includes LA 3346. What do you think LA 3346 means?
Is it the degree of the city for basically how many routes are off of it and the weight for each route?
Nope, not a weight. The first number is going to be how many arcs there are, how many cities it connects to. It's going to connect to three cities. It's going to connect to Denver, which is the third city. That's why I have that blue column. It's going to connect to Chicago, and it's going to connect to New York City. So I'm going to pause the graph, and I want you to draw this diagram based on the cities. Somebody's going to have to remind me to start the recording again. Okay, so I didn't start recording, but now I did, so I'm going to go back. Here's the drawing of all of our directed paths. Here's a little test data we made up. Denver to Miami. We would go Denver to LA, all the way to New York to Miami. What if the paths matched? What if this path, there was another way to go by length 3? What might you look into next?
You look
So
at fly time?
yeah, you might look at flying times next. So there's two, and when you book a flight, you'll see direct flights, one layover, two layovers, and you start to see how long the travel time is, and then the layover time comes into play. And so, but Paul, if we could just get this started code wise, again, we already know a solution. Put all of this into a matrix, multiply it by itself, pick your starting point. I could say, I want to start at 1 and I want to end at 8. And then you go to that first matrix. Can I get from 1 to 8? No. Multiply the first one by the second one. Get the resultant matrix. Can I get from 1 to 8? Hopefully, there might be one way, there might be two. Then you start looking into other factors. But I would think that would be my initial inclination is to get all this data and store it in an array. Read this in, store it somewhere, read in the 3, which means read in 3 numbers, go from 0, 2 and put a 1, 0, 3 and put a 1, because remember, matrix, we don't start at 1, 0, 5 and put in a 1. Man, you're starting to get into some lots and lots and lots of code. We know the basics. I could throw you in groups and you could start to figure a lot of this out. Some bizarro stuff. So, what I want you to do is take that file that I gave you for chapter 16. I want you to load it up and run it. I want you to see if you can get some of this test data to work. I want to see if Denver to LA to New York to Miami is the shortest. And if it's a tie, do they list both of them or one of them? I'm going to put you in groups. Boo, 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 boo.